Let's talk about data. We are absolutely swimming in it. More data is being created every single day than ever before in history. But you know what? All that information is really just digital noise unless you can actually make sense of it. So how do you turn all that noise into a real advantage? Well, in this explainer, we're going to break down exactly how modern data platforms are built to do just that.
And that's the big question, right? It feels like you're drowning. The trick isn't to stop the flood. You can't. The trick is to build a system that's smart enough to actually harness its power. So we're going to walk through the 4 key stages of that system, starting from raw data all the way to real valuable insight.
Okay, first things first. Before you can do anything cool with data, you need a place to put it all. And I mean all of it. We're talking about potentially exabytes of information. That's so much data, it's like storing hundreds of thousands of high-def movies. You obviously need something way bigger than a hard drive. You need a digital ocean. And that's where object storage comes into the picture. The best way to think about it is like a limitless, super organized digital warehouse. And the cool thing is, it doesn't care what the data is. Could be a photo, a boring log file, a massive video. It just stores it as an object, all ready to be accessed from literally anywhere in the world.
So you really only need to know 2 basic terms here. The object, that's the thing itself, your file. And the bucket, that's just the container you put all your objects in. Everything, and I mean everything, in object storage lives inside a bucket. Yep, it's pretty much that straightforward.
Now this is where it gets really clever. See, not all data is the same. Just like in a real warehouse, the stuff you need every day, we call that hot data, you keep it right at the front. Sure, it costs a little bit more, but you can grab it instantly. But what about old records you might only need like once a year? That's cold data. You can store that for a tiny fraction of the cost. But here's the absolute game changer. Look at the access speed row. Even that cold, cheap data is available in milliseconds. This is a huge deal. It means you can afford to keep everything without those old school delays where you'd have to wait hours or even days to get something back from the archive.
Okay, so we've got all our data safely stored away. Great. But right now, it's just a giant pile of raw materials. To get any actual value out of it, we need to process it. We need to build a factory.
The thing about raw data is, well, it's a mess. It's coming from all these different sources, it's often inconsistent, maybe it's missing pieces, or it's just plain disorganized. It's like digital ore. All the potential is there, trapped inside, but you need some pretty powerful tools to extract it, clean it up, and shape it into something you can actually use.
And this is our data factory. We're talking about managed services built on incredible open-source tools like Hadoop and Spark. What they do is break these massive, overwhelming jobs into smaller pieces and then run all those pieces at the same time. But the most important word on this slide is managed. Instead of spending weeks or months trying to build this processing factory yourself, you can just spin one up when you need it, get the job done, and then shut it right back down.
And this comparison really shows you the massive advantage. If you tried to build a processing cluster yourself, it could honestly take you weeks, maybe months. With a managed service, you can launch one in about 90 seconds. This completely changes how you work. You can create a super powerful cluster just for a single job, and then, poof, delete it when you're done. You only pay for the minutes you actually used. It's a huge shift from that old world of buying giant expensive servers that just sit around doing nothing most of the time.
All right, we've done the hard work. Our data is stored and it's been processed, it's clean, it's structured, and it's ready. Now, this is where the magic happens. We can finally start asking the real questions and uncovering the secrets hidden deep inside all that information.
And really, this is the whole point of everything we've done so far. Now we can go way beyond simple reports. We can ask really complex questions across petabytes of data to find patterns you'd never see otherwise. Questions like, which marketing campaign actually led to more sales? Or what sequence of events tells us a customer is about to leave? These are the kinds of game-changing insights that were basically impossible to find before.
But to ask questions of these gigantic data sets and get answers back quickly, your data has to be organized in a smart way. So we use techniques like partitioning and clustering. Think of it like creating a super efficient index for a massive library. Partitioning your data by date means when you ask a question about last month, the system only looks at last month's data, not your entire 10-year history. Then clustering sorts the data within that month, making your searches even faster and way cheaper.
And right here, this is where things get truly mind-blowing. Modern analytics platforms are putting machine learning directly into the hands of data analysts. You no longer need to be a specialized data scientist with a PhD to start building predictive models. I mean, the slide says it all.
If you know how to write SQL, the language of databases for decades, you can now create a model to forecast sales or predict customer behavior. This is a really big deal because it puts the power of AI into the hands of so many more people. It changes everything.
So, we've just built this incredible data pipeline from end to end. But let's be honest, none of it matters if it isn't secure. And in a modern platform, security isn't some feature you just bolt on at the very end. It's more like an invisible guardian that's there with you through the entire journey. It all starts with this one simple but incredibly powerful idea, the principle of least privilege. What it means is that nobody and no thing gets a blank check to do whatever it wants. So a program that only needs to read data can only read data. It can't delete it. An analyst who works with marketing numbers can't go snooping around in sensitive HR files. Everyone gets exactly the access they need and absolutely nothing more.
So you might be wondering, how do you possibly manage this at a huge scale? Well, you do it with a really clear hierarchy. Policies are inherited, so they flow downwards from the top. You can set a broad security rule for your entire organization, then get a little more specific for a department's folder, then even more granular for a specific project, all the way down to a single file. This gives you that perfect mix of high-level control and fine-tuned flexibility.
When you boil it all down, this whole complex system of identity and access management, what we call IAM, is really just about answering three very simple questions. Who is making the request? What are they trying to do? And which specific resource are they trying to do it to? That's it. Every single security policy you create is just an answer to those three questions, giving you precise, laser-focused control over your entire platform.
And that really is the key takeaway for security. Modern cloud platforms are designed from the ground up with security baked into every single layer, from the physical concrete of the data centers all the way up to the services you're using. It's not an afterthought, it's the bedrock you build everything on.
So we've gone on this whole journey, right? We started with a flood of raw, messy data, and we turned it into a refined, secure, and incredibly valuable asset. We've seen how to store it, how to process it, how to analyze it, and how to protect it. So now, the only question left is, honestly, the most exciting one. What are you going to build?